Let's be honest. Most people treat their home lab's operating system like a default checkbox. They grab whatever's trending on Reddit, slap it on a used Dell, and call it a day. But in 2026, that's like building a race car and filling it with lawnmower fuel. The OS isn't just the foundation of your lab, it's the nervous system. It decides how fast your containers spin up, how reliably your backups run at 3 a.m., and whether you can actually sleep through the night without a panic-inducing alert. I learned this the hard way after 3 years of chasing stability with the wrong kernel, the wrong package manager, and the wrong assumptions. So before I tell you what I'm running, I need you to understand why the choice matters more than ever. Because in a home lab, your OS is the difference between a hobby that works for you and a project that works against you. So let's talk about the operating system that holds my entire lab together, Proxmox. I didn't choose it because it's trendy, I chose it because it's boring in the best possible way. When you're running agentic workflows that need to spin up a dozen containers at 2 a.m., you don't want surprises. Proxmox gives me enterprise-grade virtualization with KVM and LXC baked right in, and it does it through a web UI that actually works. No SSHing into a terminal at midnight to debug a broken grid. No fighting with raw config files just to get a VM to boot. The integrated backup system is the real killer feature. I can snapshot an entire VM, clone it, and roll back in under a minute. That's not a luxury, it's a necessity when you're experimenting with AI pipelines that might accidentally delete half your dataset. And because Proxmox is built on Debian, I get rock-solid stability without sacrificing the ability to install custom kernels or tweak ZFS pools. It's the hypervisor that lets me sleep through the night, knowing my lab will still be running when I wake up. Now, once Proxmox has laid the foundation, I need something to do the actual work. That's where Ubuntu Server steps in, not as a flashy newcomer, but as the quiet, reliable workhorse that never complains. I've tried Alpine for its tiny footprint, Fedora for its cutting-edge packages, and even FreeBSD for its legendary stability. But every time, I keep crawling back to Ubuntu. Why? Because in a home lab that's increasingly driven by AI agents and automated pipelines, I need an OS that just works with everything. Ubuntu's package repository is absurdly vast. If there's a tool for container orchestration, machine learning, or workflow automation, it's either in the default repos or a single backport after the backport away. And when I'm integrating with Claude or other AI tools, Ubuntu's seamless support for Docker, Podman, and Kubernetes means I can spin up a containerized workflow in minutes, not hours. The long-term support releases are the real secret sauce. I don't want to rebuild my entire automation stack every 6 months because a kernel update broke my Python environment. With Ubuntu LTS, I get 5 years of security patches and stability, which is exactly what I need for a lab that runs 24/7. It's not the sexiest choice, but it's the one that never lets me down. And then there's the storage layer, the part of the lab that quietly holds everything together. For that, I rely on TrueNAS Scale. I know, everyone talks about TrueNAS like it's some kind of sacred cow. But here's the thing. When you're running AI training pipelines that generate terabytes of data every week, you can't afford to lose a single byte. That's where ZFS comes in. TrueNAS Scale gives me enterprise-grade data integrity with checksums, snapshots, and self-healing capabilities that actually work. I've had drives fail in the middle of the night, and TrueNAS just quietly rebuilt the pool without me even noticing. But the real reason I chose it over other storage solutions is the built-in S3-compatible object storage. In 2026, my lab doesn't just store files, it stores operational logs, AI training datasets, and container images that need to be accessed from anywhere. With TrueNAS Scale, I can spin up an S3 endpoint in minutes, and my AI agents can pull training data directly from the storage layer without any custom scripting. It's the kind of integration that turns a storage server into a strategic asset. And because it's built on Debian, I can run Docker containers right alongside my ZFS pools, turning my storage node into a lightweight compute node for log processing or dataset preparation. It's not just storage, it's storage intelligence. Finally, let's talk about the operating system that handles the invisible work, the lightweight agents that monitor, report, and execute without hogging resources. That's Alpine Linux. I deploy Alpine on edge nodes and minimal footprint services because it's built from the ground up for efficiency. The entire OS fits in under 100 megabytes, and it runs on hardware that would choke on a full Ubuntu install. When I need a container to scrape logs every 5 minutes or a node to run a simple health check, Alpine is my go-to. Its security focus is another huge win. Alpine uses Muscle LIBC and OpenRC, which means fewer attack surfaces and no system debloat. In a home lab where every CPU cycle counts, Alpine lets me run dozens of agents without breaking a sweat. And because it's designed for containers, I can spin up a new Alpine-based service in seconds, integrate it with my monitoring stack, and forget about it. It's the OS that does its job so quietly, you almost forget it's there, until you realize your lab is running faster and more reliably than ever.